All right, let's try another one. How to find the value of an unknown term. In the previous ones, we knew the first term and the last term, but we didn't know the number of terms. Now we're going to switch out our unknown. We know the first term. We know the sum of all 12 terms. That means we know the number of terms that there are. We need to figure out what the last term is. This one is one where if we be very specific with how we write it out, it'll be fine. Let's go ahead and list out what we know. My number of terms is 12. I have that from this. My first term is 14. I know the sum, that is 564. Find the last term. That means A of n, or actually technically I could say my 12th term because I know there are 12 terms. Okay, well, when in doubt, let's write it out. Let's write a formula. I know that the sum is equal to the number of terms times the average. Let's kind of plug in some things here. The sum is 564. Number of terms is 12. The average, I'm going to have to do a little bit of work on this one. The average is the first term, which is 14, plus the last term, which I don't know. I'm just going to say the last term, divided by 2. And basically, this now becomes my unknown. If you want to do, like, just put in an X in here, but this is what I'm trying to figure out. So how do I figure that out? Lots of different ways. I could see I'm going to divide these by that right away, and I get 564 equals 6 times 14 plus the last term. I'll go ahead and divide by 6. Why not? Subtract 14, and we get 80. The last term is 80. Woohoo! Are you ready for a challenge? Here we go. Find the number of terms in the finite, which is very important. We know that it will end, arithmetic series below. Let's see. So they've already written it in series forms, which means we're adding or subtracting them. But that means my first term is -12. My second term is -8, my third term is -4, so on and so forth, until I get to the end of my terms, which I don't know because that is, but when I add them all up, I get 2,220. Ooh, how would I even go about this? Here's our strategy. We're going to write down all the formulas that are going to apply to arithmetic sequences, identify what we know and what we need to find out, and then how can we use our formulas to get there. And just be aware, there are going to be many steps, and we might even see our friend the quadratic. Quadratics are helpful in many ways that we don't even look for. We need to label and be very organized, so let's just start. Well, the two formulas that I have used so far, I'm using my sum. So sum is my number of terms times my average. Now, with this one, for my average, I need to know my first term and my last term. And I don't know my last term, so I can't figure out and I don't know what n is. I have two unknowns here. I don't know the number of terms, and I don't know my last term. So I have two unknowns. This is not going to be very helpful yet. What was the other one? Well, I did know this one. My nth term is equal to my first term plus my common difference times n minus 1. How could I use this? I'm going to start with this one. What could we do? My nth term, which I don't know, I need to find that out, is my first term plus my common difference. Oh, well, I can figure out my common difference. -12 to -8, -8 to -4. We're moving up by 4. Times n minus 1. Okay, well, I have this. I'm going to go ahead and simplify this because it looks kind of gross. I'm going to say plus 4n minus 4, and then I'll combine those, so I get 4n minus 16. I kind of just did a couple of steps in there. So my last term is going to be 4 times the term number minus 16. So if it was the 10th term, it would be 4 times 10 minus 16. Okay, well, I think that will help me because now I can plug this into here, and I think that might be helpful. Let's see what happens. My sum, which I know, that's 2,220 equals the number of terms, which I don't know. But my first term, my average is going to be my first term plus my last term, which is this. So plus 4n minus 16. That's my last term. So first term plus my last term. And average means we're dividing by 2. Oh, look what happened here. Now I have an n. I only have one variable, which is n. I can solve this if I only have one variable. Let's simplify this though. It kind of looks gross. Now I'm looking at this and saying, this reminds me of a quadratic. Yes, I am going to use our friend, the quadratic, to help me solve this. And if I see a quadratic, I think I want to set it equal to 0 because then I can factor or use the quadratic formula. So I'm going to set this equal to 0 to get this amazing thing. Well, I noticed that all of these are even, so I'm going to scale everything down by 2, which is fine. Oops, 7n. And that's a little bit easier. Now, factors of 1,110, I don't really feel like doing that. I'm just going to go straight to the quadratic formula. So here we have x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now x, in this case, it's n, but that's okay. I'll go over here. We have negative b, so the opposite of negative 7, which is positive 7, plus or minus the square root of b squared. Negative 7 times negative 7 is 49, minus 4 times a times c, all over 2 times a. Here's where I'm going to get my calculator out. Yay, calculator. I'm going to figure out what's in my square root. Let's see, 49. I have 2 negatives, which is going to be a positive. So 4 times 1 times 1, 1, 2. That's fun. 4, 4, 8, 9. All over 2. Square root of 4, 4, 8, 9 is 67. 7 plus or minus 67 over 2. Now, move that up here. 7 minus 67 divided by 2 is going to give me negative 30, which I know I can't have negative 30 terms, so I'm going to just cross that one out. That sometimes happens when we're dealing with quadratics. And 7 plus 67 divided by 2 is going to give me 37. That means n, which is what we were trying to find up here, is going to be 37. There are 37 terms in this arithmetic series. So notice with this challenge, it wasn't impossible, but we did have to use 2 formulas to get where we needed to go and use our friend, the quadratic formula.